Hello everyone, welcome to Math World. For your information, I have just launched the membership in this channel. Please join as member to get the early access to the new videos and also the access to the members only videos. And not to forget to subscribe to the channel so that you will be notified on the posting of the new videos. Thank you everyone. Okay, so let's start our video today. Okay, so this video is to discuss modulus functions from the algebra chapter, which is from paper 3. Okay, so first of all, for this modulus function, okay, basically we will look for the definition. Okay, after that, the graph, sketching. Then lastly, we'll be solving the equations and the inequalities. Okay, so I will be covering these three parts in this video. So first of all, for the definition, alright, basically the modulus functions means that it is an absolute function. So it can be defined as modulus x equals to x when the x is positive value, or I would say it is 0 and above, or when the x is less than 0, which means it's any negative values, then modulus of negative values, it will be always positive value. So we have to times a minus to that. Okay, so this is the first definition. Now the second definition for this modulus function is modulus x is square root of x squared. So generally, modulus functions means it's a function which is always positive. Okay, therefore it is defined as the modulus x equals to square root of x squared, so that it will be always positive. Alright, so we will be using these two definitions to solve the equations and inequalities. Okay, so now the second part of this modulus function is the graph sketching. So when we look at the graph, okay, let's say for example we need to sketch y equals to modulus x plus 1. Okay, let's say now to sketch this graph, we will always start with the function without the modulus. Alright, these two lines are called modulus. So we just ignore the modulus line first, then we are sketching y equals to x plus 1. Okay, so we know that this is a straight line because the degree of the x is 1. Okay, so now to sketch a straight line, we just need 2 points. Probably I will just let x be 0, then my y is going to be 1. And then when my y equals to 0, my x is minus 1. Okay, so now when I sketch, so I will mark 2 points. X is 0, y is 1. Let's say here is 1. And then x is minus 1, y is 0. Basically, I'm getting these 2 points. So when I join these 2 points using a straight line. Now, if I extend it to the negative part, because we can just draw up to negative infinity and positive infinity, this will be my graph for y equals to x plus 1. But then, when you refer to the definition over here, modulus means always positive. So therefore, this negative part, which is the dotted line, or I would say that it is the broken line, will be reflected to be the positive. So my reflection line or my reflected line will be here. Okay, you just assume the x is the mirror. So therefore, this whole part will be my y equals to modulus of x plus 1. So you must understand that the blue color is the y equals to x plus 1. Okay, it's the original graph, the blue color. So the red color is a reflected. So which means initially is negative. So when you refer to the definition A, okay, so when the x is negative, our answer here is actually negative of x. That means basically if I need to write down my equation of the red color over here, I would say this red color is y equals to negative of x plus 1. Okay, but if I combine the orange color and the blue color over here, the whole graph here is actually the modulus function. It's just that when we need to solve the equation or inequality later on, in case we are using the orange color line, then you have to times a minus. Okay, but the blue line just remains as x plus 1 because it is positive. Alright, so this will be the steps to sketch the modulus function graph. Okay, so done for the second part, and the third part will be solving equations and inequalities. So now, when we need to solve inequalities, okay, we have two formulas over here, or I would say there will be two identities. Okay, given m is a constant. Alright, so for the A, modulus of x less than m, this m is a constant, means that it is a number. Okay, so it can be written as x in between minus m and positive m. Alright, and for the part B, or the second formula, that is referring to modulus x greater than m. So when it's greater than m, which means your x is greater than m, or your x is smaller than minus m. So we will be using these two formulas in solving the inequalities later on. Okay, so that's all for the notes of this modulus function. So let's go through some questions. The first question is solve the following equations. So A, modulus of 4x plus 5 equals to 2. Okay, so for this case, I will be applying the definition because you have one modulus. So the definition here is going to be the first part. Okay, so it could be positive and it could be negative, which means I will just change this x, okay, into positive x and also negative x. Then I will be able to solve the problem. Okay, so now for the first question A. Modulus 4x plus 5 equals to 2. Okay, basically, what we need to do here is, you can say this whole value is 2. Okay, or this whole value is minus 2. Alright, because we know that modulus of 2 is 2, modulus of minus 2 is 2. Right, because of this. Or another method is you just change it into minus 4x plus 5 equals to 2, or 4x plus 5 equals to 2. Okay, so it depends on you, where do you want to put your negative. But I personally recommended the negative will go to the constant, then it will be easier, right? So then from here, what I do is I will just write my 4x plus 5 equals to 2, or 4x plus 5 equals to minus 2. Then from here, you can easily solve the x. So which means the 5 move to the right side. So 2 minus 5, it becomes minus 3. And your x is negative 3 over 4. First solution is found. And the next one is 4x equals to this 5 move to the other side, becomes minus. Total will be negative 7. And hence your x is going to be negative 7 over 4. Okay, so that's all for the solution of A. And now for the B, modulus of 3x minus a equals to modulus of 4 minus x minus 4a. So now, for this question, you have two modulus instead of one modulus. So what to do is, same as just now, you consider this as positive and negative. Okay, and here is also positive and negative. Right? So now, basically, if you look at here, supposedly there will be 4 cases. Okay, so let me show you. The first one is both positive. Okay, or the first one positive and the second one is negative. Or the third one will be first one negative and the second one is positive. Alright, or the last one will be both negative. Sorry, both negative. So this will be 4 different cases, but okay, generally the first one and the last one will be the same case, because I can just simply cancel off the both minus. And the third, and the second, okay, and this second and the third will be the same. Alright? Because you just move the minus to left or right side. So which means here, instead of considering 4 cases, I will just consider first 2 cases. Okay, so it depends on you where do you want to put the negative for the second case. So now let's solve this question, which means now my solution is going to be 3x minus a equals to x minus 4a, or 3x minus a equals to negative of x minus 4a. Okay, so now I will just group the x together and the constant together. So I will be getting 2x equals to minus 4a plus 1a. That is going to be minus 3a. Okay, so now my x will be negative 3 over 2a. Same goes to the next one. So here I will do the expansion first, times the minus to the whole bracket. It will be minus x plus 4a. This is 3x minus a. And then the x will be grouped together. And then the a will be grouped together as well. So which means I will be getting 3x plus x. That will be 4x. And then equals to 4a. The minus a move to the other side becomes plus. Therefore, 5a. And now at last, I will be getting x equals to 5 over 4a. So my solution will be x equals to negative 3 over 2a or 5 over 4a. Okay, so done for this part B. Question 2. Solve the following inequalities. Okay, so now when you look at this inequality, basically it just involves one function and one constant for both cases. So when one function and one constant, basically we can just refer to these two formulas. Okay, so that's why I have written down here, this m must be constant. If it is not a constant, you are not allowed to use these two formulas. Okay, please take note on that. So now here, for the question number 2, I will just use the formula. So since a modulus x plus 3 less equals to 1, now just recall back the formula. Modulus x less than m, that means x between minus m and m. Alright, so this is a constant. That means they are similar. It's just that now here for the question A, I have to add on the equal sign. So if I add on equal sign here, these two must add the equal sign as well. Alright, so now I will assume, okay, so one more. You need to do assumption. Now your x here, okay, the x in the formula has been changed to x plus 3. So you just change accordingly, which means now here I will be getting x plus 3 in the middle and then minus 1 and 1 at the end. Alright, so now when you solve means you need to find x, the unknown. So I need to find out the unknown of x, which means now I need to eliminate this plus 3. So basically, it can be done by subtracting 3 to whole inequality. Okay, this is a step-by-step working. So therefore, the middle part, it becomes x. And then here, the right side, 1 minus 3 is minus 2. And then the left-hand side, it will be minus 4. So this is the solution for part A. And now, for part B, modulus of 2x minus 1 greater than 4. So now here, use another formula, which is modulus x greater than m. That means your x is greater than m or x is less than minus m. Okay, so now here I will be writing, I will be modifying the formula. Okay, just change the x accordingly. So it will be 2x minus 1 is greater than 4 or 2x minus 1 is less than negative 4. And now here, remember, we need to find x, right? So keep the x on the left side and move this plus 1 to the right side. So the plus 1 move to right side becomes, the minus 1 move to right side becomes plus 1. So 4 plus 1 is 5. Hence, my x is greater than 5 over 2. Okay, same goes to the other value. So, or the other inequality, I will write 2x is less than minus 4 plus 1, that is minus 3. Hence, my x is less than minus 3 over 2. Okay, so that is my solution for question 2. Right, now for question number 3, solve the following inequalities. So now here, when you check, there are two functions. Here, two modulus functions for the first case. So when two modulus functions, right, we will not be using this third formula anymore. Okay, because this m is only for constant. So what to do here is we have to refer to the part B in the definition. Okay, when it has two modulus functions. So now I will change to square root of x squared for each modulus function. So which means now here for 3a, I will write 3 modulus x plus 4 less than modulus 2x minus 5. So according to the definition, the modulus of x plus 4 is basically square root of x plus 4 squared. Okay, less than square root of 2x minus 5 squared. Right? And now to eliminate the square root, we need to square both sides. Okay, so now for the left hand side, you have two terms, 3 and the square root, but then both with degree 2, right? Which means now here we have another formula. AB degree m is going to be A degree m times B degree m. Right? So you have to bring in the power to both, or to all the terms inside the square root. Inside the brackets, inside the brackets. So what I need to do now here is I bring in the squared. So this squared, I bring it to the 3, that is 3 squared, then end up with 9. And then this square, bring it to the square root. Okay, if I do it step by step, I will be writing this out. So 3 square root x plus 4 square, and then another square root. Then here less than square root of 2x minus 5 squared, and another square here. So basically, it's like this. This square cancel off with the square root. Okay, the square cancel off with the square root. So please do not cancel here. This one is wrong. Because if you cancel like that, that means you will be getting one value instead of two values. Alright? So now what to do here is 9 bracket x plus 4 squared. So I will do expansion in the next step. Now, since this is a square of two terms, then you need to expand using quadratic formula. So square of a plus b, that is going to be a squared plus 2ab plus b squared. Okay, just use the formula and do expansion. Then this will be x squared plus 8x plus 16 and less than 4x squared minus 20x plus 25. Okay, so do expansion for the left side. 9x squared plus, 9 times 8 is 72. So 72x. Then plus 16 times 9 is 144. And all these terms will be moved to the left side. So you have to change the signs accordingly. So minus 4x squared plus 20x minus 25 and less than 0. Okay, so now you have so many terms. Simplify the terms first. So 9x squared minus 4x squared, that is 5x squared. 72x plus 20x, it will be 92x, positive. 144 minus 25, that is 119, and less than 0. Okay, this is a quadratic inequality. So to solve the quadratic inequality, we need to try to factorize first. Okay, if you can't factorize it, then you have to refer to the quadratic formula to get the roots, okay, before we solve the inequality. So basically, you can just simply factorize this quadratic function or quadratic inequality using you can factorize the quadratic function using calculator, okay. So if not, you can just do manually. So 5x squared here, it will be 5x times x. Okay, after that, we have to check this. So plus times plus to get this plus. That means I will have these two symbols in the third column. So both are plus. Okay, and to get 119, okay, I need to get the factors of 119. Okay, so 119, to get the factors, it can be 17 times 7. That will be 119. Why do I choose that? Because I need to make sure later the total of these two numbers, it will be plus 92x. Okay, so now in order to get that, I have to write 17 and 7 like in this order. So 17 times 5x, it will be positive 85x. So 7 times x, it will be plus 7x. So when I cross-check, this is 5x squared when you multiply. And the last term, when you multiply, is plus 119. And the middle term, you plus. So total will be 92x. So now for the factors, just cross multiply. So I will be getting 5x plus 7 for the as the factors, then x plus 17. Okay, you can get this easily from the calculator using the quadratic function and less than 0. Now, our solution, okay, depends on this graph. So because the coefficient for x squared is positive 5, therefore the graph will have a minimum point. So when I sketch a graph, just simply sketch. This will be x-axis. So my x values will be, let these two be zeros. So when I let this whole brackets be 0, my first x is basically minus 7 over 5. And this is minus 17. Alright, so when I do labeling, minus 17 is more negative. So it is on the left side. And then minus 7 over 5 is on the right side. Okay, now, then you need to write the answer based on this inequality. Because of less than 0, that means it will be negative values. So negative values means the graph will be below the x-axis, which is a shaded region over here, which means I can accept any of the values here. That means your x values or your solution is going to be in between minus 17 and minus 7 over 5. So this will be the solution of this question. Okay, so now part B. So when you look at the parts B here, you have one function, one linear function, and another one is modulus. So when just involve one modulus and the other one is also a function, we are not going to use the definition anymore. Okay, so what we need to do is we need to refer to the graph. So this question I will solve using graph. Alright, so I will sketch the graph first. So it means that the B will be 2x minus 1 greater than modulus x minus 2. Okay, so now I will have to sketch both graphs. So let y1 equals to 2x minus 1 and y2 equals to modulus x minus 2. Okay, so now for the y1, I let x be 0 because it is linear function, so we just need 2 points. So when x equals to 0, your y1 is minus 1. And then when y1 equals to 0, my x1 is going to be 2x minus 1 equals to 0, so your x is half. So now I get 2 points. And for the y2 equals to modulus x minus 2, remember just now, we have to ignore the modulus first. So I will let y equals to x minus 2. So your x equals to 0, your y equals to minus 2. And when y equals to 0, your x is going to be 2. Okay, so now I sketch both graphs on the same diagram. Okay, so for the first graph, 0 minus 1. So this is a point. And then half 0. So here is half. So join these 2 points using a straight line. Okay, so this is a straight line. And this is my y equals to 2x minus 1. Okay, another graph will be y equals to x minus 2. So x equals to 0, y is minus 2. So this is my point. And then when x equals to 2, y equals to 0. Now remember, we need to sketch modulus graph. But we ignore the modulus sign first, which means you should realize that the modulus graph never have negative. So for the y values, okay, which is negative I, you have to use dotted line. Right? So you use the dotted line to join the y values here, and then you reflect, because we need to do reflection. Make sure it is positive. Okay, which means this is a line. And then now we know that it cuts or it touches y-axis at minus 2 for the original graph. So when you do reflection for this negative part, right, all these negative parts, so it will be touching the y-axis at positive 2. So I will just reflect it. Right, so this is your y equals to modulus of x minus 2. Okay, so from here, to solve the question or to solve the inequality, I have to make sure the straight line is greater than the modulus graph. So when you look at the graph over here, straight line more than modulus graph here. Okay, straight line more than modulus graph. Alright, so here whenever it's greater than this value, this line, that means the blue line is greater than the orange line. But when it is less than that, your straight line is lower than the orange line. Okay, or the blue line is lower than the orange line. So which means I need to find out this. Okay, but I'm not sure whether this is 1 or not. Okay, this is just a rough work. So probably I do not sketch here 1. Yeah, better to sketch 1 here, okay, because we need to mark the half. Alright, so but then I have to double confirm using the calculation. So what we need to do now here is we have to calculate the intersection point. Okay, so by intersection point, basically it is an intersection point here between the blue line is y equals to 2x minus 1 and the orange line. So remember, this part is the reflected. Okay, this part is a reflected graph. So when reflected graph, we need to times a minus to the existing function. So when you calculate the intersection points, you have to be careful with that. So this one will be x minus 2. Okay, and now here I will just do expansion. For the right side, it will be minus x plus 2. Okay, then now move the x to the left side, it becomes 3x. Then the minus 1 move to right side becomes positive 3. So my x is actually 1. So I confirm that this is 1. Okay, so now the solution for the question is going to be, okay, straight line. That means my solution is basically the green color, which means I have to accept all the values which is greater than 1. Okay, so this is the solution for this question. Alright, so that's all for this video. Thanks for watching, and please subscribe to the channel if you enjoy watching my video, and share this channel with everyone. And also please join the member, and so that you will get access to the members only videos, and also you can view the videos early. Okay, thank you everyone, bye.